All right, so this video is going to introduce you to what we're going to consider the global carbon cycle. We have already learned quite a bit about the carbon cycle. If you've taken biology, you've learned a lot of the details already about it. But if you've noticed that when we talk about the carbon cycle normally in schools, we talk about it on a very small scale, right? We talk about the environment that we are currently living in the town of Williamston or something. And we look at how we are producing carbon and how plants need to take carbon, and it's really limited, right? But we need to keep in mind that the carbon cycle is a global thing. It's happening on a much larger scale. So how do we kind of break down the complexity of such a huge system? Well, there's three big parts to it. The first is we need to identify carbon pools. Pools are things that can store carbon. For example, the plants on the earth, Earth's crust, the ocean, or the atmosphere. The second thing that we need to take into consideration is time. How long is carbon stored in each of those pools? Is it in the long term, or are we talking about short-term exchanges? The last thing that we need to look at are things called fluxes. These are just processes that can take carbon from one pool and move it to another pool. Before we get into the details of pools and fluxes in particular, we need to take a look into how do we actually measure carbon, right? If we're talking on the global scale, we must be talking about huge, massive amounts of carbon, and we are. We're going to be using the unit gigatons, all right? And you're going to see it written as capital G, lowercase t, capital C, gigatons. To put it in perspective, 1 gigaton is about the same as 200 million elephants. Okay, that's huge. Another way to think about it, the average human has a mass of about 60 kilograms. That's between 120 and 130 pounds. Assuming we are made up of 18% carbon, if we took all 7.3 billion humans of the world, we would only make up 0.07 gigatons of carbon, okay? Huge amounts is what we're going to be talking about when we say carbon in the global carbon cycle. So knowing that we're measuring things in gigatons of carbon, let's go into that first idea of carbon pools. There's 4 primary pools that we're going to be thinking about. The first one is the Earth's crust. Now, there's 2 kind of things that store carbon in Earth's crust. The first is just straight up sedimentary rock, which if you've forgotten or you don't know, sedimentary rock is formed by layers upon layers of soil and other particles that are squeezed together, massive amounts of pressure, in order to create things like shale or limestone. All right, so carbon can be stored in rocks like that. The other source of carbon in the Earth's crust that we use very frequently and heavily rely on in our everyday lives is fossil fuels. And again, in case you don't know, or you just need to remember real quick, fossil fuels come from dead organisms that have been squished through millions and billions of years to create things like petroleum, natural gas, and coal, right? Now, remember, we're using that unit gigatons, right? So in Earth's crust, there's over 100 million gigatons of carbon. That is a lot. This is our primary source of carbon in the Earth. The next carbon pool that we're going to talk about is the ocean. There's a lot of dissolved inorganic carbon that sits towards the bottom of the ocean. But there is some exchange between the atmosphere and the ocean, and so some of that CO2 is going to sit towards the surface of the ocean. It holds just about 38,000 gigatons of carbon. So definitely not as much as Earth's crust, but a significant amount. The next most common carbon pool that people think of is the atmosphere. We talked about the greenhouse effect and greenhouse gases, and the most common greenhouse gas people think of is carbon dioxide. It does make up a good, chunk of our conversations. We're also starting to become more interested in methane gas, which has the chemical formula CH4. So again, the atmosphere is a pretty popular one. However, if we look at how many gigatons of carbon are actually in the atmosphere, currently there's just about 750 gigatons. So compared to, again, the Earth's crust, not a whole lot, but very important for the movement of carbon across the globe. The last carbon pool that we need to know about and care about are terrestrial ecosystems. This is everything ranging from plants and animals, soils, and the microorganisms that live within it, including bacteria and fungi. It's important to note that when we talk about those things, we're talking about whether they are living or if they're dead and decomposing. And as far as how much carbon is stored in those terrestrial ecosystems, it's only about 3,000 gigatons. This video, I'm not going to play during like this time. You guys can watch this on your own time, but it just shows how different carbon sources can be classified into those 4 different carbon pools. Skip to the next slide. Oh, is it actually going to play? Oh, there we go. So the other part that we talked about were these things called fluxes. And fluxes are just any movement of carbon from one pool to the next, right? So you're pretty familiar with the diagram on the left. That's like the carbon cycle. We're talking about the arrows parts of those diagrams. How do we move carbon from the ocean to the atmosphere, or from the atmosphere to the biosphere, and every other which way in between? It's important to note that every single carbon pool that we've talked about can have several fluxes that can bring carbon in or out. And this is all happening at the exact same time, constantly, day, night, no matter the season, no matter the year, right? And that's what really adds to the complexity of the global carbon cycle. Now, some examples of fluxes that we've dealt with previously and we kind of already know about, one of the big ones we talked about is photosynthesis, right? Plants using carbon dioxide from the atmosphere in order to create the energy they need to grow. Another thing that we talked about that's opposite of photosynthesis is using like animals and plants using or producing carbon dioxide through cellular respiration. Animal or plant decomposition is another flux. Fossil fuel combustion is another flux. Or you can even just think about how we talked about like deforestation. That's a huge flux that changes carbon from one place to another place. And the last one that we already mentioned in like Unit 4 stuff was volcanic eruptions and how that adds to our atmosphere. So what your job is now is to go to the gizmo. You're going to be looking at the carbon cycle, in particular in this next chunk. It's going to be a little bit tricky, a little bit time consuming, just because it's a massive puzzle, right? The global carbon cycle isn't just straight and narrow, black and white. There's a lot of different components coming into play that you have to kind of manipulate and see, you know, where one thing can lead to the next. So that is your job right now. If you have any questions, don't hesitate to ask me.